You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Reining in the expanding Earth. If you pick up a globe and study the way distant shorelines would seem to fit nicely if they were somehow brought together, it might not seem all that silly to allow for the possibility that the Earth has changed its size, significantly. Imagine that globe shrinking in your hands, but the familiar continents staying the same size. Closer and closer they would get to one another as we went backwards in some hypothetical timeline, until they all slotted neatly together. Antarctica nestled between Africa, Australia, and India, Greenland filling the space between North America and Eurasia, until you held in your hands a solid rock ball. Today, of course, the notion that the Earth got into its present configuration by expanding from a smaller size seems silly. It seems to belong with the flat earthers and the hollow earthers and all the other geophysical crackpots. But how would you react if I told you that expansionism was actually a mainstream theory, and not all that long ago? And further, if I told you that contractionism, its opposite model, enjoyed a similar mainstream status. As recently as 1900, contractionism was in fact the leading model of the Earth's geodynamics, with expansionism a close second. Mobilism, an umbrella term for theories like continental drift and eventually plate tectonics, was considered the realm of crackpots. So it turns out that a skeptical look at the expanding Earth theory, and as we'll see, in its day it did indeed qualify as a theory, is not just a case of poking fun at nutty YouTube channels. In recent years, one of the most visible proponents of the expanding Earth has been the famous comic book artist Neil Adams, who posted a YouTube animation way back in 2007 explaining the idea. Adams died in 2022, but that video has had millions of views and was influential in reviving the expanding Earth concept among today's conspiracy theory and alternative history crowd, the type who will believe anything that's on Ancient Aliens or on YouTube, so long as it contradicts mainstream science. This is unfortunate, as it's an undeserved legacy for Adams. He had to endure 20 years of being called a crackpot, for nothing worse than adhering to an old idea that, although currently thoroughly disproven, had been mainstream in its day when he had been a young man. He made a series of more than 20 such videos, and they are generally in line with what was a leading geophysical theory for nearly a century. Where Adams breaks with the traditional theory is in the mechanism for the expansion of the Earth. In his modern version, it was the creation of new matter at the quantum level, a notion that science was just beginning to be aware of around the time that plate tectonics took over as the dominant geophysical model, and the expanding Earth was discarded. We can get a fair snapshot of the state of geophysical models right around the turn of the 20th century. In the late 1800s and early 1900s, science was still groping for explanations of why the continents appear to fit together, how various mountain ranges were formed, and what forces drove these mechanisms. Competing models included the Earth contracting as it cooled. They included the Earth expanding via various mechanisms. They also included various models for continents moving around on a constant-sized Earth. Contractionism, believe it or not, had been the leading geophysical model worldwide at that time. This theory holds that as the early Earth cooled, it contracted, as molten rock and most other substances do when they cool. Geophysicists believe that as the Earth shrank, its rigid crust buckled, and this buckling was responsible for mountain ranges and many other features. It was never an ignorant or crackpot theory. Contractional deformation remains today our explanation for what happened on the planet Mercury, which is crossed with thrust faults. Models suggest that the diameter of Mercury has shrunk by some 7 kilometers. Even on Earth's moon, we find features that are believed to be the result of thermal buckling, both expansive and contractive. And so, by no means was the contracting Earth theory wacky or unscientific. There are plenty of features on Earth that could aptly be alternately explained by contraction, It was only later, when more geophysical knowledge came in, that the model was found to no longer be compatible. Among other things, radioactivity was discovered, with the result being that the Earth would continuously remain heated from within, thus preventing thermal contraction. Continental drift was an idea that arose about this time, which was an incomplete hypothesis. It recognized that the continents moved around, but did not include a mechanism. This was the brainchild of Alfred Wegener, arguably the father of modern science-based geology. Based on multiple lines of evidence, he first published his hypothesis of continental drift in 1912, but he also recognized its weaknesses. The idea, from Wegener and others before him, was that the continents, not continental plates, which were unknown at the time, but the land masses themselves, floated slowly around the Earth into their current positions. The idea had been around for some 300 years, but had never gained traction. Following Wegener's publication, others proposed mantle convection as a possible mechanism, and more geophysicists signed on to the model. But not all of them. A number of Earth's features could be explained equally well by the planet having expanded, breaking apart the supercontinent Pangaea and placing the continents into their current positions. As late as 1975, a paper by the respected Australian geologist S. Warren Carey found flaws, to him fatal flaws, with plate tectonics, by then the widely accepted standard model. He discussed a number of mechanisms, of varying plausibility, which would make it possible for the Earth to expand. Among them, number 1, phase change. Magma changes volume when it solidifies or liquefies. A general trend in one direction or the other would necessarily alter the volume of the Earth. Further complexities like crystallization and gas bubbles could amplify the effect. Number 2, a decrease in the gravitational constant. If the force of gravity were to gradually decrease, the Earth would expand outward. Earlier proponents of the idea had calculated that this would result in a 2 millimeter per year increase in the Earth's radius, 400 kilometers since the Triassic. Number 3, an actual increase in mass and thus matter. In earlier decades, this had been conjectured to come from absorption of energy from the ether. But by Carey's day, we knew ether was not a thing. Carey's own speculation was that with the ongoing progression toward an eventual heat death of the universe, that energy had to go somewhere. Predecessors had suggested it was being converted into matter, in such places as the center of the Earth. Number 4, a change in the ratio of an electron's charge to its mass. By now it's pretty clear that Carey was reaching. He proposed that one of the universal constants, and constant means constant, might be gradually changing over time in order to accommodate his model. Although firmly an expansionist, empirically, he said, I am satisfied that the Earth is expanding. Carey maintained a sufficiently scientific perspective that he still listed the types of evidence that would change his mind. Number 1, noting that the Apollo astronauts had placed reflectors on the moon, Carey pointed out that the optical observatories at Canberra, Honolulu, and Tokyo could take laser range-finding measurements over the course of several years, which could prove or disprove his finding that those cities were separating a few centimeters a year due to expansion. Number 2, a neutrino beam fired through the Earth from the Brookhaven Accelerator to the Cocos-Keeling Islands, a point nearly at the opposite point on the globe, could establish their distance with accuracy of a few centimeters. This could be measured over several years. Number 3, microgravity measurements with an accuracy of 3 microgals may also be able to establish whether the Earth was expanding, depending on the method of expansion. And so, through the first half of the 20th century, geophysicists were divided into the camps of expansionists, contractionists, and mobilists, those who accepted Wegener's still controversial continental drift. But then, things changed. Around the time of World War II, evidence emerged that mobilism was almost certainly correct, but not quite the way that Wegener had guessed. Rather than the continents moving around, plowing through the oceans, it became apparent that the entire Earth's surface was made of a series of plates which moved past, over, and under one another. Plate tectonics was suggested by 3 primary lines of new evidence. 1. Paleomagnetic studies proved that the magnetic North Pole had been moving all over the place. The best explanation for the idea was, and is, that the continental plates had been moving above a generally fixed magnetic pole. Number 2, geophysicists had gotten serious about seismology, and with a newly installed worldwide array of seismometers, had discovered that the world's volcanic and seismic activity was mostly found along distinct belts around the planet, belts which formed the edges of the continental plates where they contact one another. And number 3, more paleomagnetic studies discovered magnetic stripes on the ocean floor. As mid-oceanic rifts spread, magma would cool and the solidified iron-rich basalt would record magnetic north. But over the eons, there had been a number of magnetic pole reversals. These, too, would be recorded in the basalt, as stripes with reversed polarity. And so, unambiguously, plate tectonics was proven to be the correct geophysical model. Almost all the expansionists and contractionists came over to the side of the newly reformed mobilists. But not all of them. A few, like Carey, remained for a time. Today we have a whole new generation of evidence that Carey, had he continued his working life to see it, he died in 2002 but had retired from active research long before, probably would have embraced. We now have strong empirical evidence that the size of the Earth is constant, at least to within statistical significance. Today, the world's scientists have the International Terrestrial Reference Frame, first established in 1988, and which today maintains a geodesic model of the Earth accurate to within 1 centimeter. It incorporates 4 main types of data. Number 1, satellite laser range finding that measure the surface of the Earth to within 1 millimeter. Number 2, radio interferometry, using multiple radio telescopes far away from one another. Number 3, the Global Positioning System satellite network, so accurate that it incorporates time dilation. Number 4, a system called Doppler orbitography and radio positioning integrated by satellite, which precisely measures the time that ground-based radio beacons are received by satellites. Yet, while no scientific question remains today, expansionism has managed to survive, mainly among the internet conspiracy theory crowd, and driven in no small part by the license given to them by Neil Adams and his adherents to the old theories. Today's iteration is supported not by the kind of geological data that the early 20th century expansionists studied and which Adams had embraced, but by exotic buzzwords of the type beloved by undereducated conspiracy theorists. No matter what YouTube channel you might tune into to get pitched the truth about the expanding Earth, the fact remains that the International Terrestrial Reference Frame leaves no room for esoterica. So continue to enjoy your globe and to study the way continents were once arranged. But do not fall into the YouTube conspiracy trap of rejecting knowledge and evidence in favor of conspiracy mongering. How we know what we know is always the most exciting part, and it's nearly always absent in the alternative science crowd. But you know who's never absent? Why, Skeptoid's premium supporters like Steve and his skeptical Facebook page, Lena Schiller, Dean Bertram, Hudson and James Bugg from Perth, Australia. Sustainability is a popular theme in science, and the support from these premium members is what pays the bills of our nonprofit and makes Skeptoid sustainable. Please join them by becoming a member for just $5 a month at Skeptoid.com and click Go Premium. And follow us on your favorite social media for even more great content. You'll find both Skeptoid and me, Brian Dunning, on Facebook, Twitter, and Instagram. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.